Hello, this is the video of lab 7 and lab 8. So let's start. let's start by lab 7. Here is in lab 7 we have object-oriented programming in practice. Here in folder 1, in the first folder, you can see animals and pets. The main idea is demonstrates OOPA principles like inheritance, abstraction, interfaces, and polymorphism through a simulation of animals, cats, dogs, spiders, fish, and their behaviors. So let's see if the code is runnable. So here you can see the output. Spiders eat insects, animal walks with 8 legs. Spiders eat insects, and animal walks with 8 legs. Cats like to eat spiders and fish, and so on and so on. So here KOOP concepts is concept description, abstract class animal, base class with common behavior. It's like walk, abstract eat for all animals. Inheritance here is cat, dog, fish, and spider extends to animal. Uh, Interface pet defines contrast for pet. Interface pet defines contract for pet behaviors, get name, set name, play, polymorphism. Animals are referenced via animal and pet types, allowing generalizing and handling. Constructor overloading cat has two constructors, one default, one with name. Instance of and typecasting use it in play with animal method. In the play with animal method. To safely cast and call pet specific behavior. Why it matters? Because this structure teaches code reuse, loose coupling, and type safely, and preparing students for scalable open software systems. And let's move to second folder. So second folder, the main idea is implements a CRUD-based employee management system using the data access object. It's DAO pattern demonstrating encapsulation, factory pattern, and interactive CLI apps. So K design and OOP concepts. No. First of all, let's check if the code is runnable. So here you can create. Let's type enter employee's ID. So here you can implement first name, then last name, then date of birth, let's enter salary. So here you can see we created, we successfully added employee with the ID 78019. Here is his name, salary, date of birth, and so on and so on. So K design and OOP concepts, concept description, encapsulation, employee class hides data using private fields and getters and setters. DAO interface employee, DAO abstracts operations like add, update, delete, and find build. DAO implementation employee, we implement is with we implement it with employee DAO memory IMPL stores employee in a static array, and factory pattern employee DAO factory uh, creates DAO objects and supports extensibility. Interactive CLI employee tests interactive uses scanner for user interaction, making the app more dynamic, and error handling handles invalid IDs, malformed dates, and array bounds safely. Why it matters? This simulation a real-world backend system, helping you understand how applications interface with data and abstract business logic. So let's let's end lab 7 and move to uh, lab 8. So in the first folder, uh, sheet store simulation. Uh, Main idea is simulates a shared store where multiple threads try to buy shirts concurrently, teaching thread safety and synchronization. So let's check. Here you can see the output, adding a shirt to the store, total shirts in stock, creating a purchasing again, and so on and so on. So, K multi-threading concepts, concept description, thread creation, practice thread extends thread overrides run 0. Uh, thread execution, uh, two threads are started in synchronized main. A shared resource store is a singleton with a stack of shared objects. Synchronization synchronized ensures mutual exclusion during shared purchase. Simulated delay authorized credit card uses thread slip to simulate a real world delay. Race condition prevention ensures only a thread can take a shirt at a time. Singleton pattern store get instance provides a single shared store across threads. Why it matters teaches how improper access to shared resources can cause bugs, and how synchronized can prevent it, essential in concurrent systems. So let's move to second folder. The main idea here is demonstrates how a thread can be safely interrupted and how to handle interruption signals properly. So K threading concepts. So let's check if the code is running. Ah, the current value of x is 0. So let's change the value of x. while thread current is interrupted. So, key trading concepts, concept description. Runnable interface counter implements runnable run in a thread. Graceful thread termination loop runs until is interrupted becomes a true. So thread sleep and exception catches interrupted exception to break loop during sleep. Thread control via input waits for user input 8 to interrupt the counter thread. Thread lifecycle uses to is alive to show thread is alive to show thread state before and after interruption. Why it matters? Essential for building responsive applications that can gracefully handle cancellations and system shutdowns. So that's all.